Okay, so thought I would do, actually I should probably make sure my volume's on. Sometimes I turn that off. Fog of War. So there's two ways to do this, and one way is a better way, and it's not this way, but it's with shaders, which is kind of out of the realm of what PlayMaker does. But this way, as you can see, I mean, it looks fairly nice. There's nothing wrong with it. And this one's based on vertices. So it does have limitations, right? Because I mean, really, if you look at it, really all I did is put a plane above the player. But you're limited on smoothness of the number of vertices you have in these things. Like this is actually a Pro Builder mesh. So I'll show you how I did this, right? And the player's nothing. He's literally nothing. He's just a marker with a camera. There's no logic here whatsoever on the player. So we should, how do we want to do this? So we have a plane here. Not that plane, that's the ground plane. You don't need that. So you're gonna need probably two things. Like I said, like I brought in Pro Builder for this. You don't have to bring in Pro Builder. I just found it easy. So if we want a new plane, you can give it a size, and you can give it this thing, which dictates your vertices. So, for example, say I make it relatively big, and I actually drop the vertice count, and I say build. I now have this thing, and that's a big old plane. So the first thing it needs is, obviously it doesn't look much like friggin' fog, so we need to make fog, right? So I would create a new material, and this guy is going to take that material, right? So he's looking pretty plain. So I am going to swap him over to particles unlit, and I'm going to make him transparent. Multiply is probably fine, and I'm going to go black. So now we have this thing. Oh, I guess one of the other things, and I don't know, like maybe you do want to do shadows. Might add to the fog effect, but I'm just going to turn all that off. The other thing is, when we're testing where to change transparency on the vertices, we only want to be testing this thing. So I built actually no, I haven't built a layer, but let's build a layer. It's going to be called, I don't know, our fog layer, and this will be fog, and I'm going to change this guy's name even to fog too, so I don't get confused. So now we have a fog sheet. Okay, so there is one thing that we should do, and I'm going to just take my mesh collider, and I'm just going to drag it into the variables. I'm actually going to rename it our mesh. Now, technically, I have a reference to it, but I don't want necessarily to also use that. So what I want is I'm going to use a get component, and this will allow us to use or to allow us to duplicate this FSM and on whatever we want then, right? Because we're going to get the meshes or the mesh to whatever we're on. So the other thing we need is an array. So we need vertice vectors. Obviously, it's going to be a vector 3. And we need another array, vertice colors. And it is going to be of type color. And what else do we want? We want a float, I don't know, we call it reveal distance maybe. Let's put that over here. So it's in this area. What else should we have? I think the other thing, I'll add that in after. So okay, so we've gotten our component. Now we need to collect all the vertices in that mesh. And you're probably asking, how the hell do we do that? Well, I can do get property. You can always make a custom action for this as well. On our mesh, our shared mesh, I want vertices. Okay, now we have the vertices. I also want an array of the same size for colors. So let's make another color variable actually. Default fog. And let's do current color. Okay. So now the other thing we need to do is, we also need another one called vertice array length. All right. So now we need another get property, and we want our mesh. We want our shared mesh vertices length. Store that into the length. All right, now we're going to finish this one. So we've kind of initialized our start. We come over here and now we want an array get next. And we're going to iterate through vertice colors. So we have a loop and we have a done. We also need current vertice vector. We don't actually need that, I don't think, but we will need to store this index value. Okay, so we're going to loop, and done. Athena! All right, my daughter thinks our house is a jungle gym sometimes. Loop, and what are we going to do in this loop? We are going to array add into our vertice colors, even though I spelt that with a C apparently. And we're going to add our default fog. And we're going to come back here. And that's it. So this is kind of our initial starting. And if I hit play, we have now the inspector, it won't like this size of stuff happening. So we have an array of vertices of 729 vertices, right? So we have that same for colors, right? So pretty big, and it's black. So the other thing we now need to do, now that we've this, we've initialized this, we have our arrays set up, we need a set property. On our mesh, we're going to set colors, the color array. We're going to use our, I got to change that, it's going to drive me nuts. Our vertices colors. Now, I mean, technically they should all be black to begin with, but whatever. We're going to make sure that it is. So, what's next? Let's do a next frame. So this is our set color state. And we're going to come off this frame, this next frame. So this all happens in one frame, right? So yeah, I mean, like, we're big arrays and stuff. A lot of people out there will probably are probably not used to the size of the amount of actions that are actually going to be happening in each frame. Lots of times in the Discord, you'll see a lot of people that will ask questions about performance-wise and doing, you know, various calculations, and you know, it's something everyone needs to kind of keep track of. But with that said, their Unity can handle a fair bit. Let's just say that, right? So here we are, and we're looping through 700 and some odd things and building an array at the same time in one frame. So in the next frame, what do we want to do? What do we want to happen? And you can do this a few different ways. I'm going to use the raycast method, and I'm going to use raycast 2. It's on the ecosystem. You don't have to use raycast. You could use a just a player position if you wanted to. So I'm actually going to raycast from the main camera on the Z. Self distance 100 is fine. We want to store the hit point. And we want to mask, because we want this only to happen on fog layer. Okay. Now, let's do a hit event. I'm just going to use finish, because we should be hitting every frame. Like we should anyways. You could always put a check in here to go back up or something, or to go to do a wait and redo it. So we've hit our, we have raycasted downwards. Let's make sure this camera can actually see that. Is my plane? Yeah, my plane's way too high. So let's stick him like that. So we have raycasted downwards, and we have hit a spot on our plane here, right? I'm going to hide this one. We don't need this one. And we've now hit a spot. So what we need to do is we actually need to array get next, and we need to go through our vertice vectors. We have a loop, and we have a done. We need the current vertice. We also need the index value. So loop and done. So more or less, when we're done, we just want to go back up to here, and we're gonna, it's just gonna zip through real quick, over and over and over and over again for now. So on a loop, when we've raycasted down from our camera, we hit that beam and we hit this, we need to now vector 3 operator. Oh, no, first we need to do something else. Transform point. So we want the world position, our current vector that we're getting as we loop through. We're going to take the current vector, because as you've seen, they use local values to the mesh itself. We don't actually want that right now. So let's do world space vertices vector. So we're going to use this, which converts whatever we hit into this global position, like the world space. Now we need to take the world space and the hit point. We need a distance. All right, now float compare. Move this to the bottom, and if distance is less than reveal distance, we need to change the color. If it's equal, we can probably still change color. If it's over, then do nothing. So if we're doing nothing, just go back and check the next one. But if we're going to change the color, we now need to array get on the colors at index value. We'll store that as current color. Get color alpha down here. So current color, we need to store this. We haven't made this one yet, so let's call this one color alpha. And then we need a float divide. No, yeah, we can use float divide. And we're going to take the distance and we're going to divide it by the reveal distance. And now we're going to use one, and this one's on the ecosystem. That's called get floats min. And we need two values in here. We need the color alpha, and we now need the distance. And then this one's going to be set alpha. All right, so set color RGBA, move to the bottom. So current color, the alpha, needs to be set alpha. Now set array move to the bottom. So array colors at index value, set current color. So we get the color there. We're going to do some modifications to it. We're going to set the value of this color to something else probably, and then we're going to set it back into the array. And then we are going to go back and do the same thing to the next vertice. So let's test. Where is our player? So here's the, oh, you know what? We never did. we never did a reveal distance, so I'm going to go, we'll say 10. Alright, so we're not seeing anything. Now, you might find your editor will run a little slow in here because there's a lot happening. So as it iterates through, so distance, so we got that, we're getting the hit point, the distance, storing, we compare, let's go up that a bit, see what happens, see if anything's happening yet. So that's not exactly what we're trying to do. So, oh, you know what? Well, no. Normally, like you probably use a magnitude and stuff. You can make custom actions for that. I'm trying to avoid that if I can. So that's that, and this guy is on the right layer. Okay. Less, if reveal distance is less. Oh, you know what? I'm pretty sure I'm supposed to do that. If the distance is less than the reveal distance, then, you know, we should do stuff. Whoops. Right, that would make more sense. All right, so there's our distance. Let's see what's happening over here. So we get a value. Color alpha. So it should be like 3. Hold on here, I think there's something here. So distance, distance, and reveal distance. Oh, okay, no, that's supposed to be color alpha. That one's supposed to be distance. Oh wait, no, whoops, sorry. Okay, float divide the distance by reveal distance. This guy. We want alpha, and no, okay, that's fine. Alright, let's, it's a good thing I still got this one here. I can reference. So, let's see. Because we have reveal distance to distance. And if I look at this one, the one I was playing with to figure all this crap out, it almost looks the same. Some of the variable names are right loopy in this, but so distance I have it less than 50. I just used a solid value. So array get, we get the color, we store the alpha, divide the distance, alpha distance, set and set. Alright, so y, so it looks relatively the same. So here we have ray casting. Let's check the hit point. We have a hit point. I wonder if we should debug that. Okay, so that's what we're seeing. So we get from the vectors a current vector and we get an index. We're going to transform the current vector, which is that guy, which is right. We get our world space. We take our world space and our hit point from the ray. We get the distance. That's that guy. So then alright, 1 second here. I'm pretty sure because I'm using reveal distance. His less is to move on. Over here I did, I see I flipped it, but I had to change. Yeah, so okay, so that's right. And what else here? Float compare, so we do all that and we come over here. So we get the value, we get the color, we get the alpha of the color. We divide the distance. I wonder if I should ramp that up. Let's see what happens if I do that. So then we get the min from the color alpha to the distance, which is going to just return the smaller one. And then we set the color, and we set the color back in. Color alpha is 1. So it's obviously not, no, so we divide it by, oh, I wonder if I should do this. We put it into an action sequence. If that will change anything. not making much sense now, is it? Oops. Reveal distance. Distance divided by that. You know what? I wonder if I should use an operator here. Float operator. Okay, let's take it off action sequence because it just kind of looks weird for me. So, okay, so we take color alpha, divide it by, or not color alpha, get the distance. We want to divide, and we want to, now we'll use divided value. So we take the, oh, I wonder if I'm supposed to be using this one. Actually, I think I had that one technically before. So this guy will now move. And we still have an issue. Index value. What am I missing? What am I missing? Missing something simple. Oh, you know what? I used inverse. Transform point. Imagine that, eh? So current vector going into world space. Because the inverse takes world space and makes it local, where the normal transform goes the other way. All right, so now we're here. That's going to adjust all these distances. So let's go where it should be first vertice. Okay. So now we get the index value. The alpha is 1. So we take the distance, we're dividing it, we end up with 5. We look at these two values, and we set the alpha. That's literally the exact opposite. Could almost have a neat little effect though, but eh? So why is that the opposite? Unless I am doing this backwards. Distance, reveal distance. All right. Yes, okay, well, now it looks like we're doing something right. So we had a bit of a kerfuffle there. Sorry about that. But hey, we worked it out, and that's one part. So it's a little blocky. All right, so now let's fix this up. So yeah, make sure this is transform point, not the inverse, because that screwed me up. And let's go back to this, to that. And that made it a little more smoother looking, right? So now we have a much better fog of war happening. Now it's a little choppy. That's what the editor open. It's trying to repaint like a billion things, right? So if you run with that editor open, it's a PlayMaker for that. It's not going to like it. You see, it's not choppy when it's closed. It's fine. So now the more vertices you have, the better it will be. Get rid of this one. So, I mean, it's a relatively small area though, right? And if we start bringing this thing out and making multiples, the downside is now we have a whole whack of arrays happening, and that could very quickly add into some performance issues for doing that. That's, you know, starting to get up there, and that's no good. I mean, beyond that, I mean, it works fine, which is why I did it with the get component method, because I'm not worried about the logic having to set any specific values. It'll just run, right? So there is one more thing I wanted to do to this, and that's I needed that open. So if we're here, I first want to come this way, and I want to get distance, and I want to use I don't really want to use itself. You know what? That's what we're going to do. I'm going to make a marker on it, and I'm going to move this to roughly middle. The middle is going to be roughly there. Okay. So this is going to be our checker. All right. So the other thing, let's do this, just so I don't have to worry about filling this out either. Let's do find game object, or even find closest. I guess it doesn't matter. We want to find the player. I'm going to store it in a variable called player. So let's get rid of that. And let's take this guy and put him player. Go over here. Now let's get distance of our, not the vector, the target, the player. And the other one we need is our center. Now our center is going to be our little marker here. No, that's supposed to be a game object. So that's supposed to be this guy. Center to player. Center to player, and float compare. So if I were to look at, say, the player, right? Say he's roughly in the middle. Okay, I'm just going to use one of these axes. So we're at almost 5 on the Z. Well, I guess it would help if I went on the Z. And if I want to get to the edge, to which I should almost calculate it this way, I'm looking at 35 and we started at 4, so we're like 30. So let's say 40. 45, we'll even say. So if distance we can just reuse that variable is less than 45, then go work. Right, because now we should have it so it just wants to run. And if I take the player away, eventually, okay, yeah, so he's not hitting. Fair enough, fair enough. So let's do a next frame event in our raycast system. And he can go, I will use that event, do nothing. Do nothing means go back up here. Alright, now we have a little system in there that more or less flicks this thing on and off for running through the array. So that's cool. So that's part 1. Now the second thing is, let's make a prefab of this. And let's move this guy to 0, 0. I guess I should move this guy up to 0, 0, 2 then. And that plane is decided to be, well, yeah, he's a plane, this one's not. Alright, so this guy, let's move him like that. So this guy 0, 0 is now putting him in the corner. Okay. So if I were to duplicate him, right, and if I wanted to come over here and I wanted him to line up just right, he needs to be 75 units to the X. Okay. So let's happen like that. I spelled that wrong, so let's fix that because my spelling shouldn't be that bad. So let's create a variable called our fog, and let's use 2 integers, width, put it in the input, and height. I spelled that wrong. Man, you guys are all going to think I'm some sort of moron for spelling here, but whatever. Doesn't matter. Alright, so what do we want to do? We want to iterate. And this one should be on ecosystem. If you don't have it, it's actually an older style action. Actually, I almost think the newer ones have loop. Maybe I'll try to use one of the newer ones compared to the older iterate. Yeah. So let's try this one. You know what? I've never even used this one before. So let's do width, and on the loop, and we have a loop and we have a done. So what happens on the loop? We need to take a vector, to create object, fog at position, and then vector 3 add after we've created it, take position, and we're going to add, what do we say, 75? Right. And it would help if I actually gave that some numbers. So we should now have a bunch of those. And of course we got to do height as well, I suppose. So let's store, nope, set position. What we need to store this guy is to, he's now the created, and let's set the position of created. And just on the Y, let's go 4. Space cell, space world. No, we'll do space. Yeah, no, space world. This guy, is he? Yeah, he's at 0. Okay. There we go. So now we should have a whole whack of those. Now, technically, this first one we can get rid of. He doesn't need to be there. And we have, and they should be lined up just right. So we probably need 2 more. Right? So we're going to want to go to the manager and go 7 and 7. So that's for the width. So this one is, we'll do another loop, and this one's going to be for the height. And it has a loop and also a done event. And it's done can go sit over there, has done can go actually back up. Well, probably not. So we want to loop, and every time we loop, we're going to come down here and do this. When this guy is totally done, oh, he needs to feed back into here. When this guy's done, he can go somewhere else. So, but before we feed back in there, see this thing here? We now need a, we'll call it vertical. And the vertical is going to be that. So we should be able to vector 3 add x, y, z. We're going to add vertical. That was on the x. No, we want to do it to the z now. 75. So that should now give us not the right thing. Oh, yes it is. The loop. So I mean, PlayMaker has loop limits, and you can actually go in here and just literally do an override and crank those up. And I've used that a fair bit. I'm not going to actually bother with that right now. I am just going to just alter the frames. Instead of making it all happen in one frame, I'm just going to add a couple of those. So it won't be instant, but it should prevent that issue. No, we have a loop count still failed. All of these guys. All right, so I guess on these ones, let's override. Put that up. Let's see. Uh-oh. We have a little issue. So let's fix that. So as we come down here, we're adding 75 every time we loop through that. And okay, let me think here. Done this a few times when you have a loop inside a loop. So okay, you loop through the heights, and we're looping. We go down, and now we're going to loop through the width, and we do this, and we set position, and we add to the vertical. No, we don't want to add to the vertical here. So we're adding to the vertical here. So why am I doing it twice? That's just weird. So we're going to add 75 to position. And we set this thing to position. Now every time we come up here, we need to set vector 3 position. Can now go back to, I can zero out. Wait a minute here. So okay, that's not making much sense to me all of a sudden. So okay, we're looping through. We loop through the width. We're going to set position. We're going to vector add to the x. Take the position. We're adding to the x. We go through. Now, if we come up here, we need to set everything back down to 0. And then we add to the 75 to move forward and come back down. That sounds right. Does that sound right? I think it sounds right. We should have where it builds. Okay, so that's not building quite right. Because that means it's not. Okay, let's get rid of that guy. Let's. Right, because he's obviously not. We probably shouldn't be zeroing out with that guy. How about that? so why is he not moving up on his Z? Unless we are not set position. So we take position, we're going to set him to the position. Vector 3, we're adding 75 each time. Up here we set this, but then we're adding that. That should work. We're adding to the Z. Position should go in by 75 until we hit the count, and then it should go up by 75 and then restart the other count. So it does that, hits a point, that zeros, but the Z didn't go up. Why didn't the Z go up? That's the big question. Because right now, I'm pretty sure this is the wrong thing. Yeah, there we go. There's the issue. Totally missed it. Should have caught that. So now we have, it's building. And now it builds up that way. Okay. Okay. So that's working. So I'm going to get rid of, really don't need that one. I probably don't even need this in an action sequence. Alright, I think I will. So we loop, we're going to get all that, we come back here. 700, how long would that take? 10 seconds? If we were to put next frame into those. Okay, well, you know what? I'm not that worried about it. Let's just see how it looks. Let's see if everything's working the way it's supposed to be working. I gotta get a new coffee. So we're building all of our fogs. During this time, you'd probably have your camera faded out and a loading screen up or something like that. And, you kind of do that whole thing. I should probably take this guy, move him back here. We don't want nothing running yet. So now we have a whole crap ton of these things. That is a lot of vertices that we are looping through now. You imagine if we didn't put a little checker in there. Right, it would so let's see. There. Alright, so let's take a look at this guy. PlayMaker's not going to like that. There is one little thing you can actually do to help speed this portion up. Once it loads, I'll show that. So we have here the middle and the player, and the distance is that. Okay, like if you go into this guy, this type of stuff, turn that off, and it'll actually help a lot. Alright, so he's working. And he goes here, and There we go. That was the issue. So this guy needs a reference to the camera. Pretty simple fix. So let's say call that cam up here. Find game object, main camera, and your cam. All right. So let's now take our camera guy. Let's move this. I see much faster it's going with that thing with bubber off. So it's building. Well, you know, for demo purposes, I suppose I didn't really keep redoing it to 7, but whatever. It's a journey. How about that? We're all in this on a journey. All right, it's almost done. All right, now it's done. So now we have a little fog of war. And we can do all sorts of things with this. Oh, we've got a little bit of a vertices issue happening with that. That distance needs to go out a little farther. From 45, it needs to go to like 50 or 55 or something. But the general purpose of that, things are running. Right, let's do that again, but let's bring this down. We don't need a whole whack of them. And let's go into here and take this guy up to, and actually I'm going to go up to 75. I'm going to ram this right up because I'm also going to take this up. So now we should have a much bigger circle. And there's obviously more of these running with that higher distance, right? But it should be, we shouldn't be able to see any seams. Right, I mean, it looks like it's just one big sheet. And that is a nice little fog of war. So, pretty big on arrays. But works pretty good. Like I said, I mean, in reality, the best solution is by shader. But this does work. You can just sit there. It's almost kind of relaxing. It's almost like you're painting, right? But that is how we can do a fog of war. Ba-doop. It is just literally just a layer. You would never tell though, eh? And if you go like this and you turn on cast shadows, that makes those areas a little harsher. Maybe that's what you want. But I mean, if you also want that, you can also adjust some of the values in the FSM to make it a little harsher too, though. So it would be better than shadows. So there we have Fog of War. So hopefully you guys enjoyed it and learned lots, and I'll talk to you guys later.